Good morning, children. This is 9th Standard Maths, Chapter 11 Areas of Parallelograms and Triangles. In this lesson, let us learn the first topic, that is, figures on the same base and between the same parallels. Look into the first figure, in which ABCD is a trapezium and EFCD is a parallelogram. Both the quadrilaterals have the common base that is equal to DC. Common base equal to DC. And the vertices A and B of the trapezium ABCD are opposite to the base DC, and the vertices E and F of a parallelogram EFCD are opposite to the base DC, which lies on a line AF parallel to DC. Therefore, we can say that the trapezium ABCD and parallelogram EFCD have a common base that is equal to DC, and between the same parallels AF and DC. We can write it as AF parallel to DC. Consider the next figure, in which ABCD is a parallelogram and triangle PCD will lie on the same base that is equal to DC, and between the same parallels AP and DC, that can be written as AP parallel to DC. Consider another example, in which PQRS is a parallelogram and MNRS is another parallelogram. Those two parallelograms are on the same base that is equal to SR, and between the parallels PN and SR, that can be written as PN parallel to SR. Based on this property, let us solve some of the exercise problems. It is exercise 11.1. First question: which of the following figures lie on the same base and between the same parallels? In such a case, write the common base and the two parallels. Consider the first figure, in which ABCD is a quadrilateral and PCD is a triangle. Both the figures are having the common base equal to DC, and both the figures are between the parallels AB and CD. It can be written as AB parallel to CD. Consider the second figure, in which PQRS is a parallelogram on the base SR. In the same way, SRMN is a trapezium on the base SR. Hence, both the quadrilaterals have a common base equal to SR. But in a trapezium, only one pair of opposite sides are parallel, but they are not in S between SR parallel to PQ. Consider the third figure, in which PQRS is a parallelogram and TRQ is a triangle, which is having the common base equal to QR, and between the parallels PS parallel to QR, and can be written as PS parallel to QR. Consider the fourth figure, in which ABCD is a parallelogram is on the base BC, and in between parallels AD and BC. The same way, consider the triangle RQP, which is on the base PQ and in between parallels AD parallel to BC. Therefore, parallelogram ABCD and triangle RQP are not on the same base, but they are between AD parallel to BC. Consider the fifth figure in which ABCD is a parallelogram and APQD is another parallelogram having the common base equal to AD, and they are between the parallels AD and BQ. It can be written as AD parallel to BQ. Thank you.